Okay, have your notes for 12.7. We're gonna start the graphing of the sine and the cosine functions. Graph the sine curve. We start off with a warm-up problem. If you want to determine which one you're going to solve with, first thing I would do is draw A, B, C. Little a is 5, little c is 4, little b is here. I know this is 96. When we have side angle side, we're going to need to use a lot of cosines, right? So you would set up b squared equals a squared plus b squared minus 2 for c or a cosine 96, and then you could solve for b squared. Let you finish that one out on your own. Also, exact value. These are similar to some problems that you had from yesterday. What you want to do is figure out what the sine of 45 is. Quadrant 1, going to be positive for 4. 1, 1, square root 2. Sine of 45 is 1 over the square root of 2, or square root of 2 over 2. So I have 6, and then I have square root 2 over 2. Now I got to figure out what the tangent of 300 is. First thing I do, figure out the reference angle, 300. Leaves me with 60. I'm in quadrant 4, STC. Tangent has to be negative. I know this is going to be negative based on the STC. I go get my 60, 30, 60, 1, 2, square root 3. This is why you need to know these things so well. Tangent of 60, opposite over adjacent, square root of 3 over 1. I know it's negative, square root of 3 over 1. Multiply this stuff together. 6 and 2 can simplify to 3 and 1. I get negative. I have 3. I have square root 6. That's how you find an exact value, people. Good stuff. Good stuff. Same thing here, negative 210. If I was doing negative 210, first I would figure out where is 210. It's going to be 30 past. I'm in quadrant 2, so I know STC. I know it's got to be positive. I know a 30, 60, 90 is going to look like this. 1, 2, square root 3. Sine has to be opposite over hypotenuse. This is positive 1/2. Plus 3 times the cosine of 30. Cosine of 30, quadrant 1, everything's positive. Square root 3 over 2, square root 3 over 2. I get 1 over 2 plus 3 square root 3 over 2. Like terms, good to go. And exact value means leave it like this. That's the answer. So those are a couple of problems that might help you with the problems that we did from yesterday's assignment. We're going to graph trig functions now. The first thing we should probably take a look at, let me just call up, show you what we're getting at here. Actually, I got it here. No, that's the wrong one. We do the interactive unit circle, and you can kind of see everything that's going on here. So if you take a look at this, and I come down here to 0. Okay, so we talked yesterday about the unit circle where the x-coordinate is the cosine and the y-coordinate is the sine. So when we have our quadrants filled in, if I'm just focusing on sine, and if I know that my x-coordinate is 0 here, as I move it up, we know that the sine of 30, we just did it, didn't we? Sine of 30 is a half. There it is. Continue up. Sine of 45 is square root 2 over 2, which is 0.707. If you don't trust me, check it on your calculator. And then sine of 60 is square root 3 over 2, which is 0.866. And then the sine of 90, y coordinate is 1. That's 0, 1. So what we're going to be doing is we're going to take these off of this xy unit circle, and we're going to put it where the degrees is the x-axis and the value of the function is the y-axis. So you can watch the green line. This is what we're going to be graphing. As we come up, it's up to 1. There it is. We go down here. Sine of 180 is going to be 0. It's right here. I'm on the green one now. Continue around. Sine of 270, negative 1. And then our period of our sine curve is 360 because it took me to go up and down and up. I do it in 360 degrees. And the cosine, which is the blue, does exactly the same thing. So we're going to start, we're going to graph these things, and we're going to see how the curves are affected. So when I go back to, where did I go here? When I go back to my PowerPoint, wherever it ended up, let's just look at Gavin for a while. Here we go. There it is. I found it. All right. First thing, horizontal length of one cycle. So when we're talking about the sine curve, the cosine curve, we're going to talk about okay, so we're back. Let's see if we can get this going here. Okay, technical difficulties. My apologies. So when we graph these things, we are looking for our important points. 1, negative 1, 0. So if I was talking about y equals the sine of theta, or x, and this is the thetas, or x's, and this is the y's, the values, what I'm going to focus on is the period, which will be one cycle. Remember, the sine of 0 is 0. We're going to start there, and I know I'm going to end at 360. And I know halfway in between, or 180, is going to be there. I know 90 is there, and 270 is there. So if we can remember our 4 important points, where I go from 0 to 90 is 1, to 180 is 0, to 270 is negative 1, and back, this is what we're going to be able to do to draw these little graphs. And that'll work out for the period, the time it takes to get through one cycle, for sine and cosine is going to be 360 degrees, or 2 pi radians. We're only going to be worrying about sine and cosine right now. The amplitude of these ones, half the difference between the max and the min. So the max is 1, the min is negative 1. The amplitude up here, for the most part, is usually going to be 1 unit. From the midline, up 1 unit, down 1 unit, that gives an amplitude of 1 unit. Frequency, the number of cycles in a given unit of time, the reciprocal of the period. So if I'm just talking about a period being 360 degrees, then the corresponding frequency is 1/360th of a degree. It's just the reciprocal, okay? Flip it over. We're going to do a couple of problems in hertz, not the car rental. Here's the key. Whoa, whoa, whoa. Here's the key. When the one that we just had back there, we wrote as y equals a sine. Well, this is, hang on. The one we just did was y equals sine of x, or my value of b was 1, and my value of a was 1. We don't see him there. That's why we said the amplitude was equal to 1 is the value of a, the absolute value of a. So if that's negative, we always say the amplitude is positive. And then the period, 360 over 1, gives me 360 degrees for my period. That was for the general one. So this y equals a sine b to the x, bx, that's going to be what we're going to be working with in today's lesson. So if I look at this, I look at the value of a is 2. The value of b is 1/2. And if you go back to what we just said, the amplitude of this function is the absolute value of a is 2. The period of this function is 360 degrees divided by the value of b, which is 360 over 1/2, which is 720. That means we're going to get through our sine cycle in 720. Let's draw it up. Here's what you're going to do. We're just doing a rough sketch for these, getting our important points. I know I'm starting here. I know I'm ending here, and I'm going to end at 720. Halfway in between, I'm going to hit here. A quarter, I'll hit the max. 3/4, I'll hit the minimum. My amplitude was 2. My amplitude was 2. 1, 2, 1, -2. So I know that at my quarter point, I'll hit there. My 3/4 point, I will hit there. And then I do a little rough sketch of up, down, up. I have completed my cycle in 720 because the period was 720. And I have an amplitude of 2. I go from my midline. We call this the midline. We'll move that in 12/8. But right now, we're just saying up to +2, down to -2. This all comes back to the regular one, y equals sine of x. So we base it off of that. And what does that one look like? Done in 360, halfway here, max here, min there. Every single time we had a -1, we had a +1. There you go. So that's what we're going to be focusing on today, is the amplitude and the period. Cosine. What's the difference between the cosine function and the sine function? The cosine function will graph itself. If I did the regular cosine, it gets done in 360. It's halfway at 180, except it starts itself at 1. Think about the x-coordinate at 0, and then it's quarter, half, quarter, full. There you go. We get through it in 360 degrees. I have an amplitude of 3. I have a period of 360 over 2, or 180. If I'm graphing this one, I got to go up 1, 2, 3, down 1, 2, 3, and now I'm going to end in 180. Again, we're just doing rough sketches here. Here's my 90, halfway 45, halfway 135. Cosine starts at its maximum, zeroes out here, bottoms out halfway, zeroes out here, tops out here. So we've got down and up. And that's one cycle with the period as 180. Now, what if we kept this going? You could keep it going and do another cycle if we wanted to. If that's 180, that's 360, halfway 270, quarter, quarter, bottoms out halfway, gets back up. That's the second cycle. It continues back in the other direction too. All I'm looking for right now is, can you draw one cycle of the period in order to get these things going? A little word problem here. Humans can hear sounds with a frequency of 40 hertz. Find the period of the function that modifies. Okay, if it's frequency, all it is, the period is going to be the reciprocal of the frequency and vice versa. So you have 1/40th. It says let the amplitude A be 1 unit. When we do problems like this, we always have to use, we generally use radians. So if the period is 1/40th, if the period is equal to 2 pi over b, 360 over b, and that's 1 over 40. Can we cross multiply and solve this for b? B is equal to 80 pi. So if I'm going to write the equation with an amplitude and a was 1, and it wants a sine curve, y equals 1 sine, b goes here, 80 pi, they want time t. There's my equation for it. Now, how would you graph something like that? I have a period of 1/40th. That's just so awkward. And I have an amplitude. Whoa, that's terrible. We'll go with it. No, we're not going to go with it. I'm going to clear this out. Oops. We're going to go, what did we say? We said y. We said y equals sine 80 pi t. We said the period was 1/40th. We said the amplitude was 1. So if you're going to get through in 1/40th, this would be considered like a radian idea. Half of that would be 1/80th. Half of that is 1/160. So it's actually 1/162, 163, 164, 160. And if we're talking sine, we're talking start here, max out, middle, min, back there. And it's all about labeling your axis. So this was 1, and this was -1, and this is the t, and these are this is our period 1/40th, talking about the frequency being 40 hertz. So you know the sound waves. This is not. It's drawn. You can draw it with any scale you want as long as you label it up. Same idea. We've got a find the period of the function that models 50 hertz. Well, if the frequency is 50, then the period is 1/50th. write an equation, let the amplitude be 1, write the sine curve. Now I have to say, well, period is equal to 2 pi over b. All the word problems got to use the radians. And it's 1/50th. Cross multiply. B is 100 pi. B times 1 equals that. Y equals sine 100 pi t. There you go. There's your sine curve. That's it. Enjoy.